All right, hello everybody. Let's go ahead and get started. I think everybody's aware of what we're going to be talking about a little bit later on today. We're here to review for exam 3, but before we do that, I did want to talk about a couple of things as we get close to the end of the semester here. Some scheduling things to be aware of. So yes, exam 3 is this Thursday. Yes, we will have those exam grades back to you very quickly. Our grading session is scheduled for the very next day on Friday. I have had the exam grades back on Friday in the past, but it's probably more likely it'll be a Saturday. But you will have the grades back very quickly. I know that students are interested in potentially dropping the final exam, so you will be able to see where you stand in the class at the end of this week and be able to make that decision as to whether to take the final exam or not. If you do choose to take the final exam, please be aware that it is cumulative, so it does cover material from the entire semester, whereas exam 3 just covers the last three sections, sections 7, 8, and 9. The other thing to be aware of is that TA office hours are going to be ending. So the last day for TA office hours is going to be on Sunday, which is the day before the final exam. If you have homework assignments, so homework assignment 8 can still be submitted using late coupons. Assignment 9 can also be submitted using late coupons. You can submit that after the due date if you would like to. If you aren't able to get that in to TA hours on Sunday, and you would still like to use late coupons next week to submit assignment 9, that's fine. You can schedule an appointment with me, bring it into my office, and use late coupons to demo it that way. So you absolutely can still use late coupons to demo assignment 9 as well. But the TA office hours will be ending on Sunday, so just wanted to make sure you're aware of that. Yeah, and then as far as the exam itself goes, we've done this a couple times already, so nothing really different from last time. You can bring a sheet of paper with you with notes on it, front and back, just like on the prior exams. You'll be showing up to the same room that you showed up to for the prior 2 exams, so you can refresh your memory if you need to about where to go. The only thing that I wanted to make you aware of regarding the exam is that, just like we saw in the previous exam, it is not possible or necessary for you to try and remember all of the different methods that are available to you. When we need stuff like that, we look it up. We Google it, we search, we use reference materials. So the things that we looked at recently that this applies to would be the lists and the maps. We showed you how to use those things. I would not expect you to have all of that stuff memorized. So on exam 3, you'll be provided with a reference sheet. And so it may not look exactly like this. This is the one that I handed out last semester. But it will look very similar to this. Up here on the top, you can see that I've just given very brief descriptions of some of the common methods that are used for lists. And then below that, I've given brief descriptions of some of the common methods that are used for maps. I'm essentially telling you that these are the only methods that you really should need to complete what's being asked of you on the exam. I don't want you to worry about wasting your sheet of paper on stuff like this. So I wanted to show you this reference sheet, make you aware that you will be getting a reference sheet very similar to this on your exam. You do not need to use your sheet of paper to write down all of the different list methods and map methods that are available to you. So I think that's all of the reminders that I had. Does anybody have any questions about any of that logistical stuff coming up regarding the exam or the end of the semester before we hop into taking a look at some review materials? So I guess one final thing I'd like to say before starting on some review questions. I've asked this before, I'm going to ask it again. Please, if you haven't already, take a moment to log into Canvas and check out your grades in the gradebook. I have been going through everything and double checking everything and getting everything ready in preparation for the end of the semester, and I am under the impression that what is in the gradebook right now is accurate. But I know that mistakes happen, but I can't catch them if you don't tell me. So please go through your stuff. If you think something has happened by mistake, let me know. I would very much rather get that sorted out before the exams rather than after the exams. Once the exams are done, they get graded pretty quickly, and I'll ship the grades off to the university pretty fast as well. So I would much rather get any kind of grading concerns taken care of before the exams. If there's something in the grade book that has been sitting blank, it's not just going to magically fill itself in unless you do something about it. So, if that assignment, whatever you thought got graded and it's just been sitting there empty for a few weeks, you got to ask me or somebody to help you out with that. It's not just going to magically fix itself. So please do that. Let me know if you see anything. Otherwise, it's review time. So modules 7, 8, and 9 are the ones that are going to be on the exam. Module 7 is when we introduce you to objects. Module 8 introduced the concept of inheritance, and then Module 9 introduced abstract data types, linked lists, and maps being the two abstract data types that we introduced you to, although there are many more that you'll be exposed to if you choose to continue learning about computer science. Just like I did for prior exams, you were given this little practice quiz on Canvas with some multiple choice fill in the blank style questions, and then you were also given this coding repository with some code reading and code writing questions. You may have noticed that sort of exam 1 had a lot more multiple choice fill in the blank style than exam 2 did, and exam 2 had more than exam 3 does. That's not really an accident. We do expect the questions to focus more on the code reading and writing on this exam than there will be multiple choice fill in the blank style, but there will be some of both. So yeah, where would you all like to begin? At this point in time, I'm happy to answer any questions related to course materials, go over any of the past exam problems, whatever you would like. Yes?
Can we go over how to read like an override method for a code reading example?
How to read an override method?
Like how would you know when it overrides it and stuff like that?
Are you referring to...
No, I haven't started those, but if anyone knows one, that would be cool.
So are you referring to inheritance? Is that what you're asking about, or are you asking about...
Yeah, an inheritance one.
Okay, so let's talk about that. I don't know if any of the ones off the top of my head have an example or not, but I'm happy to just code up a quick one real quick and show some basics regarding inheritance, right? First thing to know with inheritance is that you get all of it. It's you inherit everything from the base class. So if I have 10 instance variables here of varying types, I'm going to inherit all of those. And same thing is true for the methods. So I might have a constructor here. I might have some other methods. Oops, I need a return type for that one. Right? Okay, so I'm just making some placeholders, right? So if class A is my base class and class B wants to inherit from it, this is where the first sort of inheritance keyword comes into play. We're going to use extends. And once I type that magic word in, class B extends A, B already has everything that A has in it. It has all of these instance variables, it has the constructor, it has the methods, it has everything. And I can prove that to you by actually, this might seem a little bit silly, but it just shows you very concretely what inheritance does, right? I can create a new instance of B and call do something on it, right? think about what this is for a second. Oh, I forgot the void here as well. I keep forgetting my return type today. I wonder what that's about. I created an instance of class B, and I called a method upon it. I am in class B. I don't see a single method defined here besides main, right? There is no method here called do something. It doesn't exist. In this class, it was inherited from A. So that is inheritance in action, right? Even though B itself does not contain any code at all, it's already inherited everything from A. So it can still do all the stuff that A does. Question?
What does new key parentheses like?
What am I doing here? It's a little tricky, maybe, perhaps. The new keyword is used when? Creating a new object, creating a new instance. How do I create a new instance of an object? Starts with a C. Call the constructor. Yeah, I'm calling the constructor. This is calling the constructor for B. Anytime you see a constructor like this with no parameters, that's called the default constructor. It usually just ends up creating default instances. It's actually a little sloppy. I've been going fast because I'm just typing up a little example. But I'm calling the constructor. I mean, maybe it would help if there was a parameter in here or something like that. Maybe that looks a little bit more like how we've been doing it in the past, but there's nothing that says a constructor needs to have parameters, though they usually do. And so your question wasn't about anything that we've talked about so far. Actually, it was about overriding a method. And so overriding a method happens when we decide, for whatever reason, that class B, or whatever subclass is doing the inheriting, wants to do something differently than the way that it's done in the base class. So A is doing something, but class B decides, I actually don't want to do it that way, right? So if I want to, I can come down here and I can override this method. And I can make it do something different. Okay? But before I do this, I'm going to comment this out for a second because I want to show you the before and the after, right? So this is the before. I haven't overwritten the method yet. I took it out just for a second. I'm still using inheritance, so the version excuse me, the version of this method that is getting run, it's the only version that exists. It's from the base class right now, right? There is only one version of the method that is called do something, and it comes from the base class, and it prints out the word something. That's what it says to do here in the base class, right? Okay. If I put this version of it in, let's put this version of the method back. Now when I call do something, right? It's got two versions to choose from. Which one is it going to pick? Well, is it going to pick the one in A? That's the base class. Or is it going to pick the one in B? I very clearly declared this as something of type B, not type A. So in this case, I hope it's very clear to see that it is in fact going to do the version of the method from type B, not from type A. So when I override a method in a subclass, the overwritten method is the one that is going to get used. The only way that I can use the one from the base class is if I create an instance of an object from the base class. So here I'm creating an instance of type A. This will do the version of the method that exists in type A. If I create an instance of type B, it'll do the version of the thing that's in type B. That might seem straightforward, that might seem obvious, right? But then here's a fun little twist on the problem. All right, I'm calling the constructor. I'm creating an instance of something that is of type B. I'm creating an instance of class B, but I'm storing it in a variable, and I'm saying that the type of that variable is class A. Is that allowed? I mean, Eclipse isn't complaining, so it is allowed, yes. What concept am I using here? It's a fancy word that starts with a P. Polymorphism. Polymorphism. There's a few different ways to think about polymorphism, a few different ways to define polymorphism. Polymorphism, I've described it as being able to treat objects differently within different contexts. So think about what that means. A B object inherits from A. That means that if an object is B, it also is A. So an object, I would say B is an A, right? Or if I was using something that had more English words, right, I would say a tiger is a cat. Tiger inherits from the cat base class, right? An instructor is a person. Instructor inherits from the person base class. That means that if I have an instructor, I can treat them as an instructor, or I can treat them as the more generic person type. It is both, right? I am both an instructor and a person. That means that if I'm using an inheritance, I can treat you either as the actual class that you are, or I can treat you as the base class that you inherit from. Either of them are okay. That's polymorphism. That is polymorphism. Sometimes it might be more advantageous for us to ignore the fact that I'm a constructor and just treat me as a regular person. That's okay. That's what polymorphism allows us to do. But which version of the method? That kind of brings us back to our original question of overriding. It is under the hood, right? Even though here I'm treating it as an instance of class A, right? It really is B. And the computer deep down does in fact know this. So even though the type of this is given as A, the version of the method that will be run is actually going to be the version of the method from B. So think about what that means. If I'm using inheritance, if I'm using polymorphism, right? I'm treating something as its base class as opposed to its subclass. It will still execute the methods from the subclass if they exist. If the methods from the subclass have been overwritten, it will still execute those. I know it's tricky. It's an abstract concept. It's a very abstract concept. You may have noticed that we did use some polymorphism on the assignment, but nothing quite to the degree of what we've been talking about on this particular problem. We're really kind of digging down into the details about how inheritance works. But polymorphism is a very important concept. Being able to treat an instance of an object either as its actual class or as its base class is a very important concept. So I'm very happy to talk about it. Yeah, question?
Do you mind elaborating on this? Like A is now like B kind of? It acts as B class?
Other way around. The subclass is an instance of the base class. In this case, A is our base class, B is our subclass.
Yeah.
So I would say B is an A, not the other way around. A cat is not a tiger. A tiger is a cat. So tiger could inherit from a cat base class. That makes sense to me, right? I could say a tiger's a cat, but the other way around, not true. I cannot treat the base class as one of its subclasses. Yeah.
So the constructor has nothing in it. So like, what is it? First of all, how does it know that like those two open parentheses are calling that constructor? And then also like, what is it actually doing since there's nothing in it? Does that make any sense?
So I mean, this is not good practice. The constructor, I definitely skipped over the constructor to get to the overwrite the method part. But to answer your question, I mean, this is still a constructor. This is the name of the class that we're in. I don't know what else. I mean, we've created a class called B. So anywhere I see the letter B followed by parentheses, ergo must be the constructor for that class. The end. That's how it knows. I mean, I don't know how to explain it other than that. But what happens to the instance variables? Undefined, limbo, bad place that we don't want to be in. Write a constructor, set them to something. That's the proper way to do it. I skipped it for the sake of time, not because it was a good idea, because I was trying to get to something else. Good question, though. Great question. If I wanted to fix it, let's talk about it. Let's fix it. If I wanted to fix it, what would I do? I would actually want to come in here and, set these to be some actual values so that they're not just some weird, whatever limbo values that they may or may not be, some ambiguous, nebulous thing that they may or may not be. And I'd also want to define a constructor for B, right? Make this explicit. Perhaps even call the superconstructor for A. There you go. Now it's a little less ugly. Sorry that I went so fast through that part before. It's definitely a reasonable thing to ask me to go back and clean that up. Any other questions about, I would love to chat more about inheritance while we're on the topic, or if anybody has questions about what we've done. We've actually, I think, covered the big things about inheritance, at least for this class. There's a lot more that you can do with inheritance, but for this class, what did we talk about? We talked about how to actually do the inheritance with the extends keyword, using super to refer to the base class, and then overriding methods. Those are the big things that we saw with inheritance. So I wouldn't worry about too much other than that. Polymorphism, talked about that. Yeah, what's up?
Why would you write it like line time?
Why would I?
Yeah. How would you say B?
Okay. We definitely would have seen an example of this, perhaps. The studio, I think, is a great example. Creating the quiz class. Multiple choice question is a question. But what do I have on the quiz? I have a list of questions. So being able to refer to multiple choice questions as just generic questions helps me a lot, because then I'm able to have a linked list of questions that can accept both regular questions and multiple choice questions. I'm able to treat multiple choice questions not as their direct type, but as the base class. That allows me to have them all in one collection, as opposed to having a separate collection for multiple choice, separate collection for true false, separate collection for fill in the blank. Right? By having the inheritance tie all of those together, we can have one common collection. Very powerful tool. Yeah.
I guess I'm confused about polymorphism. Is that on the quiz? There's like a question about which one would be an invalid statement.
I believe you, but I have no idea what that question is without seeing it, I have no idea.
Can I say it out loud?
You can, but I have a feeling that without visibly actually seeing the question, I'm not going to be able to understand it. Yes.
Can you explain, give an example of when you would use a linked list over an array list? What's the benefit of using a linked list?
For this class, we didn't even talk about that.
I just mean in general, not specifically for inheritance, but just in general, when you would.
I would be happy to talk about that, but probably not during a session dedicated for exam review, since that is absolutely not going to be on the exam. We haven't
That's on the exam?
We haven't talked about it. That's not even come up as a thing ever.
But in the studio, didn't we have linked lists? Studio?
We sure did.
Yeah. That's not on the exam?
Linked list will be for sure.
Okay.
You asked me what the difference is between a linked list and an array list is,
We
though.
haven't gone over array lists? Okay.
Yeah. There is a difference, and I'd be happy to talk to you about it, but this is not the time, I don't think. I'd like to talk about stuff that'll be on the test. Question, yeah.
Yeah, so for the exam coding writing question 1, I was confused how to get pretty much I was just confused with the occupied rooms.
Okay, sure, yeah, let's take a look at it. Code writing question 1. We wish to have a dormitory class. You were given a simple little student class to use to, store in your dormitory class, right? when you're asked to write code on this exam, this is actually the form a lot of the questions are going to take. You're going to be presented with a list of HAZAs, right? So where those HAZAs are a direct relationship to the instance variables. I don't know why I drew such a blank on that. Yeah, so there's going to be an instance variable to represent the name, and then there's going to be an instance variable for this one, which you can probably already tell by the somewhat complicated description that this is going to end up being our map. There's also an import that's also kind of a clue that we're going to be using a map for the. Oh, well, actually, I should have scrolled down a little bit. We already gave you the instance variables for this one. On some of the problems, we didn't give you the instance variables, and you had to write them yourself. But for this one, you got the instance variables, so that's good. You are asked to write the constructor. So when you're writing the constructor, remember the constructor's role is to make sure that the instance variables are all set. That's the constructor's role in life. So the question is, how does that happen? There's really only two choices. Either it's going to come in through a parameter to the constructor, or I'm just going to set it directly. I'm just going to set that instance variable to some known value. And so you can see here for this constructor, it's saying that it should only have one parameter. And so the question is, all right, is that parameter going to be used to set this instance variable, or is it going to be used to set this instance variable? And so if we think about it for a second, right? If I'm constructing a brand new dormitory, how many of those rooms are occupied? Once the building is brand new, the construction workers are done with their power tools and have all left, the rooms are empty, completely empty. So I think what we're going to do is use the parameter for the name and then just construct an empty hash map to be ready for students to come in to occupy those rooms. So let's go ahead and piece that constructor together for the dormitory. I'll set the name using the parameter. The hash map, I said I want to be empty to reflect the fact that the dorm is empty once it's first created, but we still have to do something with this instance variable. We're still responsible for making sure that we have an empty hash map. Or in other words, hash maps are objects. Objects must be constructed before they can be used. So the constructor is the appropriate place for that to happen. I'm going to call the constructor on this hash map to set it up and make it empty. There we go. That's our constructor. Any questions on that before we move on to the rest? Yeah. Right here? Yeah, that's a good question. So I actually don't need to put the types here, but you can. You can see that if I type them out, Eclipse doesn't get unhappy about it, but it's not necessary. I usually don't. You do have to put them when you declare. So this is the declaration. If you're thinking about it in terms of, like the equal sign, if it's on the left side of the equal sign, then I have to put these values in here. If it's on the right-hand side of the equal sign, then I don't actually have to put them inside the angle brackets. It's a good rule of thumb. All right, let's scroll down and take a look at the remaining methods. There's almost always going to be, a couple of simple getters down here, which I hope are very straightforward. These should just be quick and easy fill-ins for you, hopefully. To get the number of occupied rooms, okay, that one's maybe a little bit less straightforward. So we have this map that's keeping track of what rooms there are. If this were an array, right, then I could say something like rooms.length. But this isn't an array. .length doesn't exist for a map. Maps are objects, so actually we need to refer to the documentation. In fact, if you look at the reference page that you'll have available to you on the exam, you can see that there is a method for maps called size. That's probably a better way to access the size of our map. So let's go ahead and try to use the size method instead. There we go. There's one entry in the map per room. So the size of the map tells me how many occupied rooms there are. Here, I'm actually going to add a student. So it says, all right, take this student, stick it into this room number. The operation to get things into a map is called, anybody remember? It's on the reference sheet, but you can look it up. This one right here, put. And maps require two pieces of information. We actually saw that when we were talking about the types here, right? This first type is the type of the key. The second type is the type of the value. So this is going to be like a room number and then the student who is staying in that room. And so if I want to add something into that map, I'm going to use the put method. I'll say rooms.put. There we go. Thanks, Eclipse. Smart enough to help me fill that out a little faster. Okay. We now want to see if a room is occupied or not. If I plug in a key to a map and the map doesn't know about that key, hasn't seen that key before, what is it going to tell me in return? Does anybody remember? Null. Yeah, I think I heard somebody say it's going to say null. Maybe that's not what I heard, but that is what it'll say. It'll say null. And so if we want to see if a room is occupied or not, we can actually try to plug in the key, again, using our reference sheet. The get method is used with a map. So I'll say rooms.get. I'll plug in the room number. If this is equal to null, I know that the room is not occupied. It's empty. There's nobody in that room. So I'm actually want to look to see if it's not equal to null. Return that value. If I plug this room number into the map and it says that there's a student here, right? It's not null. It gives me back a student object. I know that that room's occupied, right? All right. And then finally, for this class, it wants us to create a list of all student IDs that are currently in this dorm. So we have to think about that for a second. The map is not storing student IDs. The map is storing student objects. The student objects contain student IDs. So I have to go through the map one at a time, pull out each student, and then ask each student for its ID and stick that into a brand new linked list. This is actually a pretty complicated method compared to the ones that we've been solving up until this point. Let's break it down. I'm going to start by creating a linked list to hold my student IDs. So this is just an empty linked list that I'm going to use to store my student IDs. I need to iterate through my map. In order to iterate through a map, I have to use a for each loop. I can't use a loop like this. Why not? Why can't I do something like this? Why won't this work? Anybody know? This works for lists. I could write a loop like this to go through a list, a linked list if I wanted to, but I couldn't use a loop like this to go through a map. I'm saying that I probably have to use a different type of loop, maybe like a for each style loop. We've seen these before, right? Why? That's the real question. Yeah. There you go. Maps don't have any order. Maps don't have any order. When I write a loop that starts from, I equals 0, I less than blah, blah, it's counting up 0, 1, 2, 3, 4 in order, just like the elements from an array or the elements from a list, which are stored in order. Maps are not stored in order. We cannot iterate through them as though they have an order. We have to access through them, not via an index, but by the keys. So the way that I like to iterate through a map is using a for each loop to iterate through the set of keys. So for each room, and then again, on your reference sheet, you'll see there's something here listed as key set. You could also use entry set. I provided an example in the practice code for Module 9 that iterates through a map in two different ways, one using key set, one using entry set. I don't care, it doesn't matter, they both will get you there. I'm going to use the key set, so I'll say rooms.keyset. So in this loop, I have this string room that's going to take on each of the keys from my map. I'm going to plug it into the map. That's going to give me a student. All right? I'll store that into a variable. I can then retrieve the ID from the student using the corresponding getter from the student class. And what we want to do with that ID is put it into our linked list. So I will say IDs.add s.getID. And then finally, once that loop is finished, you need to remember to return the completed linked list that contains all of the student IDs. This is not the only way you could have done this, but you do need to use a for each loop. That is a fact. If you're going to iterate through a map, you have to use a for each loop. So that's why we see the for each loop here. A couple of different ways you can do it. I don't really care which, but I would expect them to look kind of similar. There is one more part to this problem that I do want to do down here, but before I scroll down and take a look at that, does anybody have any questions about the dormitory class, how I've coded that up so far? Yeah, in the back. So the angle brackets will be used for basically any abstract data type that you run into, because the abstract data types are used to store data, and the type of data that gets stored depends on whatever it is that you're doing. So the angle brackets are just a way to provide flexibility. For one application, maybe I need strings. For the other one, maybe I need doubles, but it's always going to be based around whatever abstract data type you're using. So in this class, we've only showed you two. We've only shown you lists and maps. But if you go on and take 247, you'll see that there are a lot of other abstract data types in the world, like graphs, trees, tries, I don't know, others as well. And you'll see angle brackets appear with those too. Yeah. Another question. For each loop? Yeah, okay. So this part of the for each loop here is going to set up my loop variable to iterate through all of the keys of the map. So if I think about the maps, a map as having key value pairs, right? So there's a whole bunch of keys and a whole bunch of values. I'm starting with the keys. I'm going to look at each key one at a time. I'm going to look at each key one at a time. This line is going to take the key and plug it into the map. So if I plug a string into the map, it's going to give me a student in return. I plug in a key, it gives me a value. That's what's determined up here, right? I plug in a string as a key, it gives me back a student as a value. That's what this contract is saying. So I use the get method to plug in the room number. It's going to respond by telling me the student that is occupying that room. The student then has a method, a simple getter method called getID, which is what we're really after. We're after the student ID number. So this line of code retrieves the ID number from the student and adds it to the linked list. Any other questions on this problem before I scroll down and look at the main method? Yeah?
The heading of the for each loop, like the first part.
This part?
Yeah.
Okay.
Explain what you mean.
So this is setting up the loop variable. This is like a variable declaration. This is similar to saying, for int I, right? Except here, since I'm iterating through the keys, and I know that the keys are strings, I'm going to use string. What do the keys represent? A key is literally a room. So the variable name I chose is a room. So every time through the loop, this is going to take on a different room number. That's the idea. And so this is just the set of keys. So you can think of this as all of the keys that exist in the map. So I'm basically saying, you know, I want this variable to take on one value from this set the first time through the loop, and then another value through this set the second time through the loop, and then another value from this set the third time through the loop, until you've run out of values.
So the name of that string should match the parameters, like parameter dot get.
Yes, absolutely. This is a key. Yes. Any other questions? Great questions. All great questions. Yeah, what's up? Mm-hmm.
Will it return like the key or the not?
So when I call get on a hash map, it's going to give me back a value, if it can find one, right? The danger of, you know, not using a for each loop to do this, like I can call rooms.get whenever I want, but if the value that I plug in here is not a key, not an actual key that exists, then it's not going to find a value, and it's going to say null, which is probably not what I want. So that's why we use this loop. This loop ensures that I'm only checking keys that I know to exist in the map. I'm never going to get null here. I'm only checking keys that I know to exist. Let's scroll down to this main method, because there's one final part of this problem, which is actually, I think, a very important part of this problem. The first thing that it does is it asks you to create an instance of the dormitory class and store it in a variable called dorm. So it didn't tell you what dorm you had to create or anything like that. It just wants you to create an instance of the dormitory class. So we have to call the constructor, right? So I want to see the new keyword, dormitory, and then we have to figure out what parameters we need. Here we go. So it just needs a name, sure. Mud, sure. That's a dorm, right? I think I've been there before. All right. I don't go to the South 4A very often, to be honest with you. Create an instance of student and add it to the dorm. You can choose which room to add it to. Okay. So let's go ahead and create an instance of student. Me, new student. And what does the student constructor want? It wants just an ID number. Doesn't even want a name. That's very impersonal, but that's okay. Does not even really matter what ID number you choose. Not the point of the problem. To add it to the dorm, we have to remember that there is a method up here specifically for that purpose that expects a room number followed by a student. Okay, so I'll say add student with a room number, which I'll say is, I don't know, A123, and then me as the student. What's the problem? You can see Eclipse is mad. Didn't I do it? A dot. So I've called the method, but this is a big difference between how we used methods for this part of the class versus how we use methods prior to this part of the class, right? Methods for this, starting on module 7, when I introduced you to objects, the methods that we started using require an instance in order to operate. And that's where the dot comes in. So I'm trying to use this method, but like which dorm? I need to say which dorm it's operating on. I need to have an instance. So here I'll say dorm.addStudent, right? Otherwise it doesn't know which dorm I'm trying to add it to. You can imagine that I could create a whole bunch of these things, right? And then if I just say add student, that's not specific enough. It's not specific enough. Which dorm do you want to add that student to? These are non-static methods. So one question that I get asked a lot, starting around this time, is what's the difference between static and non-static things, right? We've been using a whole lot of non-static stuff for the last few weeks. In fact, pretty much everything I ask you about on the exam is going to be non-static methods, meaning you need an instance of the method. You have to construct an instance of the method using the constructor before you can call that method upon an instance. Contrast that with how we did things before. So from Module 6 and Module 5, when we first started learning about methods, we didn't know about objects yet. We were just using the methods by themselves. We were not using any objects, just the methods. Those are static methods. So static methods are used when we do not wish to bring an instance of an object into the equation. It's just the method by itself. That's the difference between the two. So definitely keep that in mind. And then finally, we want to write code to see if a student with the ID of 1, 2, 3, 4, 5, 6 is in the dorm using the appropriate methods. Okay. So we want to see if a student with the ID of 1, 2, 3, 4, 5, 6 is in the dorm using the appropriate methods. So if I look, this one's a little tricky because if I look at the methods that are available to me, I might first be tempted to come to this isOccupied method, but that's going the wrong way. That's asking for a room number and telling me if that room's occupied or not. I want to know if a particular student is in there. So I need to get the list of all of the student IDs and then see if the particular student ID that I'm looking for is on that list. That's how to solve this problem. So I think it's actually a two-step problem that we need to do here. You can do it all in one line of code, but I might split it up into two just to make it a little bit easier to see. The first thing that I'll do is I'll retrieve the list of student IDs from the dorm. From there, I want to see if, a particular student ID is in this list. Again, referring to our reference sheet, I can see that there's a method called contains. It'll return true if it contains that value and false if it doesn't. That sounds exactly like what I need. So I could just say something like IDs.contains 1, 2, 3, 4, 5, 6. Oops. This will return true if that particular student is in the list and false if that particular student ID is not. Again, you could do it all in one line if you wanted to. I wouldn't have a problem with that, but splitting it up, also perfectly fine. Any questions about this part? Yes?
So if that were a question on an exam, should we also display that in some way, or is that just fine?
Didn't ask for it.
Okay.
No. I mean,
Yeah.
didn't ask for it.
And then a quick question on maps. Are maps always going to be like the input A and then output B, or could it have multiple things in there, like an A, B, and C index? So like in our hash map, we have a string and student, and then have like a string student and like another something else.
Great question. So, all right. Yeah, great question. So, could it have, like some other stuff? No, it could not. It's always going to be key value pairs. It's always going to be a pair. Plug in a key, get a value. However, we never asked you to do this on an assignment, I don't think, or a studio or anything like that. And we won't ask you to do it on the exam either. But since you asked, I'll give you a little bit of a food for thought. I could do something like this. So I plug in a room number and I get a list of students back. Now that allows me to have more than one student in a room if I want to, right? So I can actually have a list within a map, or the opposite's true too. I could have a map within a list if I wanted to. So we can take these abstract data types and combine them in different combinations. Again, don't freak out too much. You won't need to do that on the exam, but is it something that people do? Yes, absolutely, 100%. That's a useful thing to do. Absolutely. And if you take other comp sci classes, you'll end up doing something like that sooner or later. Great question. Any other questions on this problem? Yes?
So in the main method, when we created the instance of like student and then set a new instance variable in the main method to call the IDs?
I'm not sure I follow. You lost me somewhere along the way of that question.
Yeah, sorry, I don't know how to ask it right, but like the IDs dot contain, there is no other we don't reference the ID in the main method before. Like, how does it know it's this ID that we're calling? Like, because earlier you explained that it needed to know that we're calling a specific dorm. So how does it know to go through like the specific list of IDs?
Okay, so the list of IDs is also coming from the dorm. I think that's important to understand.
Yeah.
So this method here is grabbing the list of IDs, and more specifically than that, it is grabbing the list of IDs from this dorm. So if I had 10 dormitory variables, it specifically would give me the IDs from whichever one I used right here, whichever dorm is right there.
Okay.
Right?
Yeah.
And that's what it means to call a method upon an instance, right? That's what it means to have non-static methods. This method cannot operate by itself. It needs an instance of an object. Where is that instance? Right here, directly to the left, always on the other side of the dot.
Okay.
Yep. Yeah. I get it though. It's an abstract concept. You're asking the right kinds of questions. Where are we going to next? Somebody have a different question they would like to work through? We've got time to do at least one more, I think. Yes. Number 3. Okay, sure. Be happy to. We want to create a song class. Here's our list of hasas. So we can expect to see 3 instance variables this time here, right? One for the name, one for the artist, one for the duration in seconds. This time we didn't tell you what the instance variables were. You have to write them yourself. So, the hasas tell you what they should be and how many we're expecting. So there should be 3, one for each of these. You have to decide what the type is. That hopefully shouldn't be too terribly difficult either to figure out. I think the only one that is maybe somewhat subjective is the duration. I think some people chose double, some people chose int. I don't really care as long as you choose numeric type. You didn't choose Boolean or something weird. Then that's fine with me. But the other thing that I absolutely am going to be looking for is that you mark all these as private, because that does matter to me. I do care about the instance variables being marked private. What does it mean to have an instance variable marked private? What does that actually do? What effect does that have? Yeah, in the back. You're close. It does protect people from manipulating it later, but only in certain places. It has to do more with where. Kind of, yeah. It is related to scope, yeah. The technical term, which is, I think, mentioned in the text, private is called an access modifier. By marking these as private, I can refer to them within this class all that I want to. But if I leave the song class and then I try to say .name or .artist, I can no longer do that because they are marked private. Something marked private is only accessible within the class where it is declared. I cannot access these instance variables directly from outside of this class. What do we use to get around that little restriction? There you go. Getters and setters. Getters and setters. We mark everything as private. We introduce getters and setters as necessary. Sometimes we might just need a getter. Sometimes we might just need a setter. Sometimes we might need both. Sometimes we might not need either of them, right? It depends on the program, but it gives us more control over how those instance variables are accessed. So always mark them as private. Provide the getters and setters if you need them. Okay. You're now tasked with writing the constructor for the song class. The same question as before. We know what our goal is. Our goal is to set all of these instance variables. The question is, can we say for certain what any of these are? So if I create a song for the first time, or I guess a different way of thinking about it is like, do we need the outside world to give us this information, or do I know that there are some of these things that all songs are going to share in common? And I would argue that for this problem, all of these need to be supplied via parameters from the outside world. I can try and explain my reasoning for that. Right? If I wanted to, let's say you didn't agree with me. You said, you actually only need 2 parameters here. I think you only need 2 parameters, or 1 parameter. Maybe you only need 1 parameter. Okay, that means that for one of these, you would have to say exactly what it is. So the name of this song is going to be, Who Let the Dogs Out, right? And that means that every song that gets created is going to be Who Lets the Dogs Out, which is a fate that I would not wish upon anybody, right? That's not what we want. When I create a song, I want to be able to tell you what the name of the song is. Maybe I want you to create Who Let the Dogs Out, but I probably don't. Probably want you to create a song with a different name, so I'll tell you what the name of the song is, right? Or, same thing for the artist. If I don't take artist in as a parameter, I'm still responsible for setting it. So if there's not a parameter to set here, then I have to say what it is. And, carries strong implications. So I think parameters are good for all 3 of these in this particular case, but it is still something you have to think about. All right, we've got our getters down here, so get name is an easy one. ToString. So ToString, we've seen this method before. Its purpose in life is just to provide a human-readable, a string representation of the object. I'm not looking for a particular format here. I'm not going to check to see if you use the right type of punctuation or anything like that. I'm looking to see that you include the instance variables. That's quite literally what I'm looking for here. So, something like this would be perfectly reasonable. I'm just going to insert spaces in between just because it'll drive me crazy if I smash it all together. But, I'm not picky about the format. Could you make it a little cleaner than this? Yeah, some people might like to, label it a little bit more or something. Whatever. I'm not worried about that for the purposes of the exam. The ToString method is a human-readable version, a human-readable description of the object. It should contain a string representation of the instance variables. All right. Now the last method down here, it's called mashup. So we want to mash up 2 songs. We want to take 2 songs, we want to mash them together. The name and the artist should contain both names and both artists of the songs, right? Again, I don't care how. I don't care how you combine those things together. I just want them to both be included in whatever way you deem necessary. And the duration should be the average of the durations of the original songs. All right. I prefer to start problems like this by just constructing those 3 pieces. So let's start with the name. New name is equal to, okay, so here's an interesting a place to start with already. We've got 2 songs here, right? One of them I can see very clearly being passed in via the parameter. Where's the second song? It's this. It's this. Remember, we're dealing with non-static methods. In order for this method to be called, that means that it has to be called upon an instance of the song class, right? In order for this method to even exist, there has to be an instance of the song class that's already created, and then this method is going to be called upon that instance using that dot notation. So this is one song, and other is the other song. So we want to take this dot name from here and just smash it together. Do I want to say other dot name, or do I want to say other dot get name? Does it matter? It's an interesting question. It actually doesn't matter. You can test it yourself if you don't believe me. We are in the song class. So even though those instance variables are marked private, because we are in the song class, we are allowed to access those instance variables directly. That being said, I actually probably would prefer to use the getter if it does exist, because maybe the getter is doing something a little extra. You don't know. You don't know if maybe there's a little extra work happening in that getter. For the purposes of the exam, though, I wouldn't count it wrong either way. Accessing the instance variable directly, using the getter, they'll both get you there. Same thing for the artist. This dot artist plus other dot. There is no getter for artist, huh? So I don't have an option to use get artist. I wonder why I made that choice when I wrote this problem. Interesting. And then for the duration, we're going to average it. So it's going to be this dot duration plus other dot duration divided by 2. And got to be careful here because there's definitely some order of operations stuff going on, right? So make sure you do that first. All right, we've pieced together all 3 of the components. We now need to actually create the song. So the return type here is a song. We want to create and return this mashed up song. So in order to do that, we're going to call the constructor and pass in the values that we have determined. And that should be our return value as well. So kind of coming back to that question that I asked before about, what's the second song? If we come down here and make a couple of songs, I don't know. That is a song. What are we going to mash Happy Birthday up with? We'll mash it up with Bohemian Rhapsody. Yeah. I think we got a hit on our hands. Okay. A couple things I want you to pay attention to, right? When we call mashup, we have to call mashup upon an instance, right? So there will be an instance on the left-hand side of the dot and then another song going inside the parentheses. So in this case, the one in parentheses, that's other, and then the one on the left-hand side of the dot. In fact, this is true not just for this method, but for any method, right? Whatever this is on the left-hand side of the dot, that is this. So when I call it this way, this is S1. Other is S2. But couldn't I also do it this way? There's no reason to say that I couldn't swap the two. And now if I did it that way, this would be S2, right? And other would be S1. So that's an important thing to understand. Because this is a non-static method, it must be called upon an instance. The instance that it is called upon is referred to as this within the class. This is a special keyword that we use to refer to the instance that the current method is called upon, or the instance of the class that we are currently operating with. Any questions? Any questions about this problem? Yeah, what's up? Okay, so you're asking, instead of creating a new song, could we have just manipulated like the existing song? Am I understanding that properly?
Yeah, and just return this.
Okay, you certainly could do that. The instructions, though, do say a new song should be created and returned. So to me, that very clearly means you got to call the constructor, make a brand new song. But to answer your question, could I just manipulate this directly? Yes. As a matter of fact, I could do something like this, right? I mean, that's the difference that you're asking about, if I'm understanding your question properly. I could just do something like this and manipulate one of the two songs directly. Pay attention, though, that means that one of the two songs that I had is now gone. It's changed, right? The old values are gone. And when I create a mashup, that's not true. The originals still exist. I've got a new one. So I would argue that doing it this way is less destructive. Yes?
How do you know which instance variables we need together if we're learning ourselves?
Yeah, so great question. How do you know which instance variables need a getter? So we need getters when I'm trying to access an instance variable from outside of the class that contains it. So if I'm writing code, right? In this class, you've hopefully seen as time goes on that programs get bigger and bigger and bigger. I mean, this last assignment, you've got what, like 4 files, right? So you can imagine that it's possible to have a lot more than that, 20 files, and they're going to be referencing each other, right? So if I'm in a different file and I need to access this instance variable, and I can't, it says it's private, well, that's my indication, put in a getter, and then call the getter from that other file. That's when to put it in. On the exam, though, I'm probably just going to tell you, yeah, a little more straightforward. Any more questions? We've got like it's kind of an awkward amount of time. I'm happy to do more questions. Not sure if I can do a full. Did you have a question?
Yeah, could it go with two-string method?
The two-string method? Sure. Yeah, let's chat about two-string method. Again, I don't care about what you stick in between. What is the two-string method's role in life? The two-string method, here, let's actually talk about it, right? What is two-string method for? When I try to print out an instance of an object, it has to decide what it's going to show me on the screen. What does it show me? It shows me the result that it gets from two-string. So if I just print out an object directly, that is equivalent to calling two-string and printing that out. That's exactly the same thing. That's what two-string really is for, to provide a human readable version of whatever this object is. So you can see that if I run this, I get the output, Bohemian Rhapsody by Queen with a duration of 500. So what should I contain in the two-string method? It should contain, I hesitate to say all of the instance variables, because you could have a lot of instance variables, and I don't know that I want to put 100 instance variables into my two-string method, but it definitely should contain the important ones. And for the purposes of this problem, there's only 3 of them. They're all important, in my opinion. So it should include all of the instance variables concatenated together as one big string. That's what two-string is for. It's as simple as I can explain it. Yep. What other questions are out there that I can address for you? Any other questions? Yeah, I mean, I'm happy to stick around and answer some more questions if you all have any more questions. I don't think I have enough time to go through a whole nother full coding problem in just 10 minutes. So I guess I'll go ahead and wrap it up here. I'll stick around, though, for the 10 minutes. If you have more questions, please come up. Please come chat. I'm happy to stick around. I want to help you get as prepped for this exam as you possibly can. So with that in mind, I also have office hours later this week. The TAs will be in studio on Wednesday and Thursday. I'll be around the labs on Wednesday and Thursday as well. So come on in. If you need to demo assignments, ask questions, whatever you need. And have a good rest of your week, okay? I'll see you in labs. I'll see you at the exam.